Alright, so I wanted to start off this unit on exponential and logarithmic functions by giving you access to a video that would just be review information. If you looked at these notes and you were really comfortable, you probably don't need to watch this video. If you looked at these notes and you're like, yikes, I need some help with this stuff, that's actually absolutely what this video is for. So if you have additional questions about any of these problems, of course, please see me. But this video should help clear up anything that you're having trouble with. Like with any video, feel free to fast forward. If they're like parent functions, we just put them. If you're comfortable with these parent functions, graph them and go on to play. If you feel like you need to see them graphed again, that's what it's here for. So use whatever pieces of this you need to, please use. And let me know if this was helpful, because like many things, this is a little bit of an experiment. So exponential logarithmic functions are inverses of each other, which means that they undo the other operation. This is very much like addition and subtraction and multiplication and division. These are equivalent statements. Y equals b to the x is the same as log base b of y to the x. I like to work with this guy. Here's your base. Here's your exponent. And this is what is on the other side of the equal sign. So that's how you go back and forth. For this direction, if you're going to turn that into a log, I put the log in. There's the base. Here's what you're taking the log of. And this is on the other side of the equal sign. B to the x equals y. And we'll do that a bunch on the other side of the notes. But first, we want to review the parent functions. Y equals 10 to the x is the first parent function we're going to look at. We didn't graph that quite as often as e to the x with transformations, but here it is. 10 to the x has a y-intercept of 0, 1, and 10 to the first power is 10. It has this horizontal asymptote at y equals 0. Its inverse is log base 10. Here our base is 10, since there's no base shown. For log base 10, our key points are 1, 0 and 10, 1. And we have a vertical asymptote at x equals 0. And you guys know by now I'm not a prolific artist, but that's a pretty good graph for me. Cool. All right, those two are inverses of each other. Again, if you look at those ordered pairs, they are just flipped. 1, 0, 0, 1. 10, 1, 1, 10. Lovely. Let's do the same with e to the x. E to the x we worked with a little bit more in our function transformations unit just to try to get you used to it. Here, our y-intercept is the same as 10 to the x was. It's at 0, 1. Between 2 and 3. And at 2, we're between 7 and 8. Again, we have this asymptote. Horizontal asymptote at y equals 0. And our inverse, ln of x, is the same as log base e of x. It's just used so often that it has that, that little shortcut. Same x-intercept as log of x. But then we're going to flip. So we're going to go out between 2 and 3, up 1, between 7 and 8, up 2. We do have this vertical asymptote at x equals 0. So again, everything you're seeing on these little notes are as a review, which is why I'm not doing it in class. But it's so important that I wanted to make sure that you had access to it. All right, let's look at some exponential equations. If you are good at exponent rules, these are very, very reasonable. If you struggle with exponent rules, you will struggle with these. So exponent rules are a big deal. That's what we've been practicing in class. So what we want to do is get the same base. These are using exponent rules to solve the equations. Your first step is going to be get everything in the problem to have the same base. So I have 3 to the x plus 1. 3 is the base that we like. I need to change 81 into base 3. If you need to do a little work there, 81 is 9 times 9. 9 is 3 times 3. So 81 is 3 to the 4th. You need to do a quick factor tree there. I love it. And then once you have the same base on both sides, you can cancel your bases. That means x plus 1 is equal to 4. X is equal to 3. So here with our 1/5, in this next problem, we have base 5. I like base 5. 1/5, to get that into base 5, we want the 5 to come up. And to make that happen, we use a negative exponent. So that's 5 to the negative 1. 5 to the negative 1 is the same as 1/5. And now we have the same base, so we can drop our bases. We have the same base, and we have 1 on each side. So our flow here, same base, 1 term on each side, get it down to a single term on each side, and it takes a little work. Like on number 7, it's going to take a little work, and on number 6. Once you have 1 term on each side, then you can drop your bases and solve. All right, this next one, I like base 5 again. Now 125 is 5 to the 3rd. So here's how that's going to look. And we're going to replace just 125 with 5 to the 3rd. And that 2x is going to stay on the outside. That's a power to a power problem there. So power to a power, we're going to use multiplication to simplify. And now that we have 1 term on each side, and they're the same bases, we can drop that and solve. Anytime we see an x squared, we know we probably need a factor. An x squared and a single x. So I'm going to move this x term over. And this is a pretty simple little factoring problem. 2 numbers that multiply to positive 8 and add to negative 6 are negative 4 and negative 2. So that means that x equals 4 and that x equals 2. All right, 2 more exponential equations. So it can be a little tricky sometimes to figure out what do you want your base to be. But you want to go small, like when in doubt, go small. So here, my smallest base is 3. So the first thing I'm going to do is get everything into base 3. 9 is 3 squared. And I have that 2x out there still. 27 is 3 to the 3rd. And I have x squared out there. And And you really can't use too many parentheses here, and you can't do too many steps. So show your baby steps here. Now we have power to a power, so we're going to multiply those guys. So I have 3 to the 4x times 3 to the 3x squared. And that 3 to the negative first power is just hanging out and waiting for us to be ready for it. All right, now last exponent rule before we can drop our bases. We can't drop our 3's yet because we have 2 on one side and 1 on the other. So we have to simplify here. But since we all have all the same base, now we can take these and we can add. Same base and we're multiplying means that we add our exponents. That's our exponent rule. Awesome. So now I can drop my bases. I'm going to reorder a little bit. 3x squared plus 4x equals negative 1. I need to be set equal to 0 so I can factor here. And factor masters can fly through this. Here, oops, I brought that 1 over. Positive 1, that's why we show our steps. 3 times 1 is 3. 2 numbers that multiply to 3 and add to 4 are 3 and 1. I'm splitting the middle here since I have that leading coefficient. My first 2 terms have 3x in common. My next 2 terms have 1 in common. If you factor by guess and check, that is lovely. If you factor by any other method, just make sure that every step is really equal to the step before. If you're using equal signs, that's important. All right, so that was a little more complicated. Had to get the same bases. Had to combine on that left side of the equation, and then we had to solve using factoring. We're going to have a similar situation over here. Don't freak out about the e to the x's. It actually is an easier problem than number 6. Okay, so e to the x. I'm going to start by combining here. The first thing I'm going to do is get rid of this fraction. So I'm going to bring this up to the numerator. And if I bring that up, I need to make my exponent negative. The other thing I'm going to do is go ahead and do this power to a power. Don't make this x squared. This is a multiply. Looks better already. Got rid of those parentheses by doing power to a power. Got rid of the fraction by using that negative exponent. Now, I'm in a situation again where I have 2 of the same bases on one side. So I need to get this to 1 base. And since I have the same base and I'm multiplying, I'm going to add there. You can write that as e to the 2x plus negative 3, or you can write that as e to the 2x minus 3. Those are equivalent statements. Now that we have 1 of the same base on each side, we can drop our bases and solve for x. And again, I did that without showing it, so I'm going to make sure my sign is correct there. Add over the x squared. 2 numbers that multiply to negative 3. And add to positive 2 are positive 3 and negative 1. Lovely. All right, I'm going to do a separate video just for the logarithm stuff, And on that video, there will be solutions for the little solve algebraically practice number 1. So click over to that video if you would like to see solutions there.